Okay, let's take a look at finding equations of tangent and normal lines, and we're going to use the derivative to do that. So remember, just a quick review, point slope form, if I'm going to find equations of lines, I think the easiest form to use is point slope. Because remember, in point slope form, you have your point, which is going to be this y1 and x1. And then you have your slope, which is denoted by m. And then you have, each equation will have x minus x1 and y minus y1. So all we need to get is a point and a slope, and we can go ahead and write the equation of the tangent line. And then remember, the normal line is going to be the same through the same point, but it'll be perpendicular to the tangent line. Okay, so let's take a look at this problem. Now remember, the first thing we need is just a point. But even before I do that, I'm going to change this to f of x. Just I like to think of it as f of x. And I'm going to do one more thing here. I'm going to go ahead and I'm going to distribute the x squared so I can say 3x squared minus x cubed. Because then I can take the derivative and it's going to be pretty easy when I get there. All right, now, but the first thing I want is the point. Right, and we're given an x value, so we just need to plug that into our original function, right? You always want to find points, you want to plug into your original function because what you're thinking about is that point is on the original graph, not on the graph of the derivative. Okay, so if I go ahead and I plug this in, right, I get f of negative 2 is going to equal negative 12 here, and then we're going to get minus negative 8, which is really plus 8, right? So we get negative 4. So now I have a coordinate point is going to be negative 2, negative 4. So notice I already have my x1 and y1 here, so we'll get to that in a second. But now we want to find the derivative because we're going to plug the same x value into the derivative in order to get the slope. And then we'll be able to write our equations of the lines. So, you could use your calculator, but the derivative is really easy here. It's 6x minus 3x cubed, or sorry, 3x squared. And so now I have my derivative, right? So now I want to find the slope at x equals negative 2. So I'm going to go ahead and just plug in f prime of negative 2, and that's going to give me 6 times negative 2 minus 3 times negative 2 squared. That's going to give me negative 12 minus 12 is actually going to give me negative 24. All right, so my slope here is going to be negative 24. Okay, now remember, we talked about that's actually the slope. Here, let's go back here. That's actually the slope of my tangent line. So we'll say the slope of the tangent line. Now the slope of the normal line, right, is going to be, you take the reciprocal, which is 1 over 24, and you change the sign. So the slope of the normal line is now going to be 1 over 24. Okay, so now I can go ahead and just write my two equations of the lines right here. So the tangent line is going to be y minus a negative 4 is really going to be y plus 4. And then I have my slope of negative 24 for the tangent line. And then x minus a negative 2 is really going to be x plus 2. And now I have my tangent line. Now notice, to write the normal line, it's almost the same. It's just that my slope is going to be now 1 over 24. So now I'm done with this one. So I have my tangent and my normal line equations, and I'm done with what this problem's asking for. Okay, let's take a look at another one. So this one's a little different. It says, at what point is the tangent line horizontal? Well, what does that mean? Well, if the tangent line's horizontal, it means the slope of the tangent line is equal to 0. In other words, that's where, let's change this again to f of x, that's where f prime x, the derivative, equals 0. Okay, so we're going to try to figure out where does f prime of x equal 0? Right, well, to do that, first let's find the derivative. Now, here's one where you could totally do this by hand. It's not that bad, but you could also do it with a calculator. And the calculator is going to speed it up a little bit. So I'm going to go ahead and do that. So I'm going to go over here and I'm going to first enter my function, my original f of x, and I'm going to store it so I can take the derivative. So I have 16 over x minus x squared. I'm going to say control VAR. And I'm going to store it as f of x. Now I go menu, calculus, derivative, and I'm going to input f of x, and now I have my derivative, okay? So I'm going to go ahead and store that right away as g of x, because that's actually going to do the whole thing for me. So, you know, once I have this here, I have this stored as g of x, right? I can go ahead and I can look at this one, right? And now I can say menu, algebra, because we need to know where the derivative equals 0. So I can say solve, and now since I have this stored as g of x, I can say equals 0, comma x. Okay, so I'm going to hit enter again, and I have an x value. Now, let's record what we got so far, and then we will finish up this problem right now. So the first thing we want to record is that our derivative is now, let's go back to the calculator for a second. Our derivative is negative 2x minus 16 over x squared. So we'll record that. That's going to be negative 2x. Oops, let's go right here. Negative 2x minus 16 over x squared. And we found that when we set it equal to 0, we get x equals negative 2. Okay, now the last thing you need is that you need to go back to your calculator and you need to figure out what the y value is, right? Because it says at what point is the tangent line horizontal, meaning where the slope is 0. So to do that, I already have this stored as f of x, so I'm just going to put in f of negative 2, and I get negative 12, and now I'm done. So now I can record that. That's my y value, so y equals negative 12, and now I have the coordinate point, negative 2, negative 12, and I've solved this problem. All right, let's look at one last one. So this one says, find the equation of the tangent line to the curve x squared plus 6 that is parallel to the line y equals 1 plus 3x. Well, in order to do that, we got to think a little bit about what it's asking, right? So it's saying, find the equation of the tangent line. Well, first of all, I need to find the derivative, right? So I'm going to go ahead and find derivative, and that's actually really easy here, right? That's just 2x. So the derivative of g of x is going to be g prime of x is going to be 2x. And then it says it's parallel to the line. Well, remember, parallel lines have the same slope. And if you think of this as y equals mx plus b, where m is 3, well, then it has to have a slope of 3, right? So that what that really means is that we have to have a derivative here where we have a parallel line here, and that's going to be 3 equals 2x, right? So x is equal to 3 over 2. Okay, so I already have my slope is 3, right? But now I have an x value, and now I got to go and put that back into the original in order to get my y value, and then I can have an equation for my tangent line, right? Because remember, all we need is a point and a slope to have an equation of a tangent line. So I'm going to go ahead and go g of 3 over 2 equals, well, here's my inputting 3 over 2 into the original function, right? So 3 over 2 squared is just 3 squared divided by 2 squared. So that's 9 over 4 plus 6. I could also think of this as 9 over 4 plus 24 over 4, right? That's the same as 6 because 6 times 4 is 24. And that's going to give me 33 divided by 4. So now I actually have x, I have my point, right? I have 3 over 2 and then 33 over 4. right? We always talked about, we always say that if you have a point and a slope, well, then you can write an equation of a line. So now I'm going to write my equation of the tangent line, and that is going to be, we're going to have y minus 33 divided by 4 equals, our slope is 3, and then x minus 3 over 2. And now we're done with this one.